Very well. So when it comes to lines, we have three representations for that line. So let's write down all of them here next to each other. For a line passing a point, what point? X sub 0, Y sub 0, Z sub 0, and parallel to vector V, which is A, B, C. We have three different representations. First of all, the very first one is the vector representation of a line. Vector. The second one is parametric, that we just explained. And then we have the symmetric representation of the line. In the vector representation, we have the notation R, vector R equals to vector R sub 0 plus T times V. So let's write this point as the vector R sub 0, and this is our vector V, which in parametric form is represented by X, Y, Z equals to X sub 0, Y sub 0, Z sub 0 plus T times A, B, C, or as you saw, it is X equals to X sub 0 plus AT, Y equals to Y sub 0 plus BT, and Z equals to Z sub 0 plus CT. And finally, in symmetric form, we say that if we isolate T in each of these equations, T is equal to X minus X sub 0 divided by A, T is equal to Y minus Y sub 0 divided by B, and T is equal to Z minus Z sub 0 divided by C. T is equal in all of these equations, so you can set these fractions equal to each other. You get X minus X sub 0 over A equals to Y minus Y sub 0 over V, which is equal to Z minus Z sub 0 over C. When it comes to a line, we get different types of questions. A question might ask you to write the vector representation of your line, X, Y, and Z. Remember that this is your very first point, and this is the vector associated to that, R sub 0. Then you have the direction vector, V. And your job is to find this vector, vector R. And the line passes through the direction vector, including your point. So R as a vector equals to vector R sub 0 plus vector V. Since it's a line, this line continues from both sides. It's not just this line segment here. This line continues in all sides. That's why we have to multiply by a parameter like T. If we use the components of the vector, vector R, X, Y, Z, you can take any point on your line, X, Y, Z, is equal to vector R sub 0, which is X sub 0, Y sub 0, Z sub 0, plus t times the direction vector a, b, c. Or if we distribute t and add the first component, second component, the third component, the very first component of your vector is equal to x sub 0 plus at. The second component of your vector is y sub 0 plus bt. And the last component of your vector is z sub 0 plus ct. Or from these three equations, the parametric equations of the line, if we isolate t on one side, it means that t is equal to t in all of these cases. It means that all of these fractions are equal to each other. So we get something that we call symmetric equation of the line. Very well. So give us an example. Example for you. Question says, write equation of line equation of a line passing through the point. What is the point? 513. 513. And it is parallel to vector. What is our vector? I plus 4j minus 2k minus 2k. Very well. So equation of a line, we're going to write down the equation of the line. The line passes through this point and it is parallel to this vector. Okay, so remember that we talked about different types of equations for a line. The vector form, which says, hey, r is equal to r sub 0 plus tv. And then we said we have the parametric form. The parametric form is x equals to x sub 0 plus at. Y is equal to y sub 0 plus bt. And z is equal to z sub 0 plus ct. And finally, we talked about symmetric form. For symmetric form, we're just coming from the parametric form. So you have x minus x sub 0 over a equals to y minus y sub 0 over b equals to z minus z sub 0 over c. Okay, so r is equal to r sub 0, which we need the vector passing through the origin, starting from the origin and stopping at this point. So r is equal to 5, 1, 3 plus t times v, vector v is 1, 4, negative 2. Okay, from the vector equation of the line, we can write the parametric equation of the line. Why is that? Because r is x, y, z, which is equal to 5, 1, 3 plus t, 4t, negative 2t. So x, y, z is equal to 5 plus t, comma, 1 plus 4t, comma, 3 minus 2t. Okay, so what's the meaning of that? It means that x is equal to 5 plus t, y is equal to 1 plus 4t, and z is equal to 3 minus 2t. Okay, this is the parametric equation of the line, and the symmetric is easy. X minus 5 divided by 1 is equal to y minus 1 divided by 4 equals to z minus 3 divided by -2. Let's take a look at our visualization. So let us add an object, a vector. So our vector, what do we have here? We have, let's see, for example, 5, 1, 3. This is the passing point. Let us add another vector. The second vector is our directional vector, 1, 4, -2. These are our vectors that we have. And our line, the equation of the line that we have is 5, 1, 3. 5, 1, 3. 1, 4, -2. As you can see, you have your line. This guy doesn't give me the terminal point. So let me fix the terminal point. Six, 5, and 1. 6, 5, and 1. That makes sense. Perfect. So as you can see, this is equation of your line, which is parallel to your direction vector, your line direction vector, and this is the initial point. It means that it passes through this line. You're going to think about this. And we can continue, just plug in different values for our t. For example, if t is 2, we're going to have 7, 7, then we're going to have 9, then we're going to have our last one is going to be -1. As you can see, your line continues when we change the values for t. This line continues and it's parallel to your direction vector. Well, in this example, everything is crystal clear. We have a point on the line, we have the direction vector, we just plug them in. What if we don't have the direction vector? What do I mean by that? Write equation of a line passes through these 2 points. So here you have point 2, 4, -3. This is 2, 4, -3, and another point which is given to us as 3, -1, and 1. 3, -1, and 1. You have 2 points. Okay. Of course, I can use one of these points to write equation. But what is the direction vector? So in this case, we need the direction vector. We need the direction vector. So it means that we have to find the components of a vector passing through these 2 points. So this is the initial point, and this is the terminal point. We want to find this vector. What is the component? What are the components of this vector? To find this vector, vector v, you're going to subtract the coordinates of the initial point from the terminal point. So it's going to be 3 minus 2, comma, negative 1 minus 4, comma, 1 minus negative 3. So your vector, direction vector is 1, negative 5, and 4. This is our direction vector. Now that we have direction vector, we have 1 point on the line. We can easily write the equation of the line. So the vector equation, R is R sub 0, 2, 4, negative 3, plus T times V, T times 1, negative 5, and 4. This is our vector format, vector representation of our line. Then the parametric, it's going to be X equals to 2 plus T. Y is going to be 4 minus 5T. And our Z is equal to negative 3 plus 4T. So this is our parametric representation of the line, and the symmetric representation of the line is X minus 2 divided by 1 equals to 4. 1 minus 4 divided by negative 5 equals to Z plus 3 over 4. Symmetric representation of this line. Very well. If the question says, hey, write equation of line segment, not the whole line itself, passing through these 2 points, the equation is, so note that the equation of line segment passes through R sub 0 and R sub 1. Remember that when you have points, eventually we can convert those points to vectors from the origin. Is R equals to 1 minus T times R sub 0 plus T times R. Quick example for you. If the question says, hey, find equation of line segment, line segment passes through the previous 2 points, 2, 4, negative 3, and the other guy is 3, negative 1, and 1. And this R is equal to 1 minus T, the initial point, now as a vector, 2, 4, negative 3 plus T times 3, negative 1, and 1. So we distribute 1 minus T, we distribute T, and then the right equation of this line segment. So you have 2 times 1 minus T, comma, 4 times 1 minus T, comma, negative 3, 1 minus T, plus 3T, negative T, and T. So the equation of the line segment is 2 minus 2T plus 3T, comma, And here you have 4 minus 40 minus t, comma, negative 3 plus 3t plus t. And note that your t is bounded between 0 and 1. Okay, here. So we don't lose the initial point and the terminal point. So R, the line segment, is 2 plus t, 4 minus 5t, and negative 3 plus 4t, and t is bounded between 0 and 1. Equation of your line segment. So when it comes to lines in the space, we have different relations between the lines. You either have parallel lines, you already know that. So relations between lines. You might have parallel lines, of course. In Euclidean space, you might have line L1, line L2, and they are parallel to each other, parallel lines. It means that their direction vectors are parallel to each other. So their direction vectors are parallel. So V1 is parallel to V2. It means that if you divide the components of V1 and V2, you get a scalar, you get a number. So if we divide the corresponding components of V1 and V2, it is a fixed number. Okay, they might be parallel. The second case, they might be intersecting lines. L1 intersect L2, let's say at one point of intersection. So what's the meaning of that? It means that if you solve the equations, you can find the point of intersection coordinates by solving the equations of the lines. We can find the coordinates of the point of intersection. That makes sense. Remember that one of the special case of intersecting lines is the case that they are orthogonal or perpendicular to each other. So special case. Orthogonal or perpendicular lines. It means that the angle between them, between these two lines, is 90 degrees. So if you find the dot product between them, the dot product of the direction vectors is 0. The last case between two lines is that we have skew lines. Okay, skew lines. It means that they are not parallel to each other, they are not intersecting. L1 is here, for example, and L2 is just right here. And they have no interaction, no intersection, nothing at all, like this case. You have two lines, they are not parallel to each other, and they go to their own directions, no intersection at all. So in this case, you have skew lines. It means that if you solve the equation of the lines, we don't get any answer. It's going to be inconsistent. The system of equations is inconsistent. In this case, we have skew lines. So parallel lines, intersecting lines, you can find the point of intersection, and here you have skew lines. Give us an example. What are you talking about? Well, suppose I give you these two lines and I ask you to analyze the relation between these two. Example. Analyze these two lines. So one of them is x equals to 1 plus t. The second component, y is negative 2 plus 3t, and your z is given as 4 minus t. This is your very first line. Let us call it L1. And then the second line, L2, is 2s. Since it's a different line, we're not using the same parameter t, we're using a new parameter s. So y is equal to 3 plus s. And z is equal to negative 3 plus 4s. Okay, so remember that if they are parallel to each other, it means that their directional vector are parallel. So let us check to see, are they parallel? So V1, the directional vector for the first line is 1, 3, negative 1, 1, 3, negative 1. The directional vector for the second line, V2, is equal to 2, 1, 4. 2, 1, 4. Remember that if they are parallel to each other, it means that these two lines are scalar multiplication of each other. What's the meaning of that? It means that if we divide the corresponding components, it's equal to fixed number. So it means that 1 over 2 must be equal to 3 over 1, which must be equal to negative 1 over 4, which is false. So V1 is not parallel to V2. So it means that they are not parallel to each other. Well, are they intersecting? So to check to see if they are intersecting, we need to solve the system of equations. What do I mean by that? X and x, 1 plus t is equal to 2s. 1 plus t is 2s. Negative 2 plus 3t is 3 plus s. And finally, the last equation, 4 minus t, is negative 3 plus 4s. Okay, we have 3 equations with 2 variables. We can easily solve it. So the first equation says, hey, t is 2s minus 1. We can substitute that into the second or into the third equation to find the next variable. So negative 2, we can just simplify this or just do the substitution. Negative 2 plus 3 times 2s minus 1 is equal to 3 plus s. Okay, negative 2 plus 6s, I'm distributing this here, minus 3 is 3 plus s. What's the meaning of that? It means that 6s minus s, 5s, is equal to 8, or s is 8 over 5. S is 8 over 5. We can type that in here. T is equal to 2 times 8 over 5, 16 over 5 minus 1, or 11 over 5. This is our t, 11 over 5. Now that we have s and t, it means that it needs to satisfy the last equation. Last equation says, hey, I have 4 minus t, which is 11 over 5, must be equals to negative 3 plus 4 times s, 8 over 5. Okay, you have 20 minus 11 over 5, which is equal to negative 3 plus 32 over 5. So we have 9 over 5 on the left, which must be equal to 32 minus 15 over 5, which is 17 over 5. It says, hey, 9 over 5 is equal to 17 over 5, which is not correct. It means that they are not intersecting. They are not parallel to each other. They are not intersecting, so skew lines.